Hello, I'm Tommy Lau Biu. Now I would like to demonstrate the sniper simulator and run the simulation with different cache level, cache size, and also cache replacement policies to check whether they have any impact on the CPU performance. Let us start with a new terminal in the Ubuntu environment. Then, to run the sniper simulation, we need to set out the environment for the terminal. So we cd inside the sniper sim directory. And to make it easy, we source the setup file that's as create default to set out the terminal environment. We're downloading the package and also set out the environment variable. For example, we have installed the Python 2.7, also checking the Python version and also setting the environment variable. For example, the sniper root and also the benchmark root. Then we go inside the benchmark root. We have another run script which contain all the test cases, all the run command for each of the test case that we will cover today. For example, let's open the run script. Okay, for the run script, we will copy the modified config file to its equivalent place to override the config file. Then we will run the command for each of the case. For example, the baseline is these two commands which run for the Redis and AFT SPLASH-2 benchmark. And also we will increase the cache size, also the decreasing the cache size. And we will change the replacement policy to NRU or random. Then we will also decrease the cache level to level 2, where the default is the level 3. And also each of the run command will print out all the reports inside the sim report directory, and also copy the simulation output to a file inside the simulation report. Then after the run, we can check all the details inside the report files that will generate during the run. Okay, here we can run by source the run script. This terminal now can run the sniper simulation since we have set out all the required environment setup. Then we just wait for the simulation to finish. Simulation to be done, we can go to the reports directory that I created for the previous. And for the previous one, we can see, and for the result, we can see there are all the reports generated for each of the test case. And we can get the result from here by opening each of the file. For example, for the baseline, we open the report and also the output file that generated during the run. For the report, we can see the instruction that runs and also the number of cycles that run by the sniper simulator and the IPC value, the instruction per cycles, which is 0.41, and the simulation speed, and the computation time, transport time, and we can see also the transport fraction that might be very useful for later analysis. Then for the output file, we can see the operation of each cause. For example, number of instructions, number of cycles that run, and also each of the separated IPC value. We also can see the percentage of the idle time and the prediction rate and PKI and the cache summaries. For example, the miss rate, the miss rate of each level of the cache. and also some DRAM summary, the number of DRAM access, and we can get the result from these output files and tabulate them for later analysis. And for the result, we have run for two applications, which is FFT and also the Radix. And for the FFT, we can see the test case files. Let me show all the test case at the side. Okay, for the test case file, which means that we increase the case size, we can see it has the lowest computation time and also the fastest simulation speed. Also, it has the greatest IPC value, instruction per cycles, and lowest idle time, which means that the cache is well constrained so that it can fully use the cache by the CPU. Then the misprediction rate is almost the same also for the level 1 cache miss rate. And for the level 2 miss rate, it's also actually similar to others, but it has slightly increased when we increase the cache size for the level 3 cache size. But we can see also it has reduced the level 3 cache miss rate to only 11%, and also reduce the MPKI. This is we can say the increasing the cache size is very significant, improve the CPU performance. While the worst performance we can see here is the test case 4, which is reducing the level 3 cache size to 4 MB. And we can see here is opposite of the test case 5, where it's increase the computation time and reduce the simulation speed. It also has very small idle time, which means the cache also fully well constrained, and the miss rate for the level 3 cache also increased dynamically, and also increase the MPKI, which show the worst performance among the test case. While for the Radix, is actually show very small effect of changing the configuration. For example, when we increase the cache size with the test case 5, it actually didn't show much increasing in terms of the total time and also the simulation speed. And also the IPC, it also stay constant at 2.62. And ideal time is actually similar and not very, might be better compared to AFD. And the miss rate also stay constant even though we increase or decrease the cache size. And also the MPKI. For the overall, actually, the cache size show the significant impact on the CPU performance, while others configuration, for example, the architecture, cache level, and cache replacement policies are showing very small change or small impact to the CPU performance. So in future, to increase the performance, we can increase the cache size for a better CPU performance. Okay, I think that's all for me. Thank you. While we are waiting for the